So in this video tutorial I'll be going through how we use differentiation to find the equation of the tangent and the normal. Now the examples that we go through will be a massive range. They'll start off relatively quite easy, but also go into quite some complicated ones involving fractions, negative powers and square roots. So before we go on to find the equation of a tangent or a normal, it's important that you understand what it is we're actually looking for. So another way of looking at DYDX is for us to understand it as us finding the equation to work out the gradient of the tangent. That's what DYDX is. So DYDX is a formula that allows you to work out the gradient of the tangent at any given point on that curve. So as you can see from this diagram, we've got an original curve which is just y equals x squared, which is marked as red. Now we've got the first thing to mark is the tangent, which is the blue line, and then the normal is the perpendicular to the tangent at that point. So in this case we're focusing on point P. So the blue line is the tangent at point P, the purple line is the normal at point P. And the key thing to establish from this, that when we're asked to find the equation of the tangent and the normal, regardless of what the curve or the polynomial is, it's always going to be a straight line. So moving on from that, the next thing we need to note is now, regardless of whether you are finding the equation of the tangent or the normal, at point P, which in terms of coordinates we're just going to label as x1, y1, it's important that we follow these following 4 steps. So the first step you want to do is now also, what I'd probably recommend that you do is make a note of these 4 steps. If you'd like to pause the video to make a note of it, feel free to. So step 1 is you find DYDX. And second step is then you find the gradient of the tangent by substituting the x ordinate into DYDX. So typically in the question where you're asked to find the equation of a tangent or the normal, you'll be given at least the x ordinate. So to find the gradient of the tangent, you substitute that x ordinate into DYDX. Now to find the gradient of the normal, what you need to do is find the gradient of the tangent first and then do the negative reciprocal of that. Because the two lines are perpendicular, if you're not too sure what I'm talking about, one thing I would probably recommend is that you get refreshed by watching the coordinate geometry video on parallel and perpendicular, and hopefully that step would make more sense. Now for step 3, now sometimes with regards to questions the actual coordinate of P will be given to you, sometimes only the x ordinate will be given to you. So if you're not given the y ordinate, one thing you would need to do is to find out the respective y ordinate, and how we do this is by substituting the x ordinate into the original equation. Now this step 3 could be done before you work out DYDX, it's entirely up to you, but because you are trying to find the equation of a straight line, there are 2 bits of information you need. One of them is the gradient and 2 is a complete coordinate. So if you're not given a complete coordinate, what you need to do is substitute the x ordinate into the original equation and boom, you are done. And then the final step is then using the correct gradient, so whether it's the gradient of the normal or the tangent that you're looking for, and the coordinate, you substitute that into y1 minus y minus y1 equals mx minus x1, and you'd find the equation of the tangent and normal. So from this stage here, one thing you probably need to make sure that you're doing is making sure that you are checking in the question whether they want the equation in a certain format. So what I mean by that is they might want you to write your equation in the form of y equals mx plus c. They might want you to write the equation as ay plus bx equals c. They may also want you to write may prefer you to write the equation so that's equal to 0. So it's worth checking in the question how they want the question written. If it doesn't actually specify, then just writing it and substituting numbers into that form, it would get you full marks. But like I said, more often than not, students don't really feel more comfortable leaving your answer like this, so they would probably opt for writing it in one of these 3 ways instead. So to start us off with these examples, what I'm going to do is we're going to focus on working out the equation of a tangent of these 5 questions. Now what I've done is I've kind of labelled each of the steps I'm going to do in its 4 parts so you can relate it to the method that I've just previously shown. So let's get started then. So what I'm going to do is I'm going to try and do each of these questions in a different colour, but obviously maintain the questions on there. So what I'm going to do with question 1, I'm going to label, mark in this colour here. So the first thing we want to do is find DYDX. So if I find DYDX, that's going to be 2x, and then it's just 0. And then for the second step, what I then need to do is to find the gradient of the tangent. So the gradient of the tangent is going to be equal to, and that's when I substitute 2 into my DYDX, in which I'm going to end up with 4. So the gradient of the normal, of the tangent, sorry, is going to be equal to, so m equals 4. So the next thing we then need to do is find the y-ordinate. So what I'm going to do is I'm going to substitute x equals 2 into the original equation. So y equals 2 squared plus 3, which equals 7. So the coordinate I'm going to use is going to be 2, 7. And then finally, using this as my x1, y1, and my gradient of 4, so I'm going to use these two things here. I'm now going to use y minus y1 equals mx minus x1. So I've got y minus 7 equals 4x minus 2. And then from this, like I said, because there's no indication of how they want the question written, how they want the answer written, I could leave my answer in this form. So if you look in any mark schemes, they may say writing in this format is okay, but if you look at the additional notes to the mark scheme, they will probably give you several variations. So what I'm going to do is I'm just going to make this look a little bit neater. And so I've got y equals 4x, and then I add 7, which makes it minus 1, and there is the equation of the tangent. So what I'm now going to do is move on to example 2. So example 2 just involves a fraction. So what I might need to do with regards to this one is just do a bit of rewriting. So if I just pick a different colour, so let's just go for more contrasting colours. Let's go for green for this one. So if I look at the equation of y equals 9 over x. Now it's important that you're able to rewrite these types of equations using the rules of indices. So that's going to be rewritten as 9x to the minus 1. Now if you're not sure where that's come from, that's because it's 9 times 1 over x. And 1 over x could be written as x to the minus 1 using indices. Now writing it in this form makes it a lot easier for me to differentiate it. So again, I'm going to differentiate the equation in this form. So if I move the power to the front, so it becomes minus 9, and then lower the power by 1, so it becomes minus 2. Then step 2, what I then need to do is substitute the x ordinate, which in this case is minus 3, into dy dx. So I'm going to get minus 9, and then it's going to be minus 3 squared. So it's going to be minus 81, because 3 squared is going to be 9. 9 times minus 9 is minus 81. And then I then need to find the respective y-ordinate. So y equals 9 over minus 3. So therefore that equals minus 3. So the coordinate I'm working with is going to be minus 3, minus 3. So substituting this all into what I've got, I've just realised I've made a mistake, so I'm going to stop there. So moving on to question 2. Now before I do, I'm just going to move to another colour. So let's work with green. Now as you can see, in this particular question, I've got y equals 9 over x. Now that in itself is going to be quite difficult for me to understand what's the power going to be, what do I need to move to the front, how do I lower the pi by 1. So using the rules of indices, I can write this as 9 times 1 over x, which then gets written as 9x to the minus 1. So now working with dy dx, if I move the power to the front in this here, then I get minus 9, so because minus 1 times 9 is minus 9, and then I get lower the power by 1, so it becomes minus 2. So now to find the gradient of the tangent, what I need to do is substitute x equals minus 3 into dy dx, so I get minus 9, and I'm going to get minus 3 to the power of minus 2. And if I just quickly work that out, so I've got minus 9 times 1 over bear with me. minus 3 to the power of minus 2, I get minus 1. So the gradient of the tangent is going to be equal to minus 1. So now what I need to do is find the respective y-ordinate. So y equals 9 over minus 3, which then, lo and behold, becomes minus 3. So the coordinate I'm working with is going to be minus 3, minus 3. So using this as my m, this as my x1, y1, so if I just label that, so that now is my m, this is my x1, y1, going back to my green. So all I need to now do is substitute this coordinate in and this gradient into the form of the equation of a straight line. So I've got y minus minus 3 equals minus 1 x minus minus 3. And if I simplify that, I get y plus 3 equals minus x minus 3, because that becomes a plus. And then simplifying this further, I get minus x minus 6, and there is the answer to the gradient of the equation of the tangent. So moving on to example 3, so let's just get rid of all of that. And just get rid of that. And so with regards to question 3, again, very, very similar. So again, I'm just going to pick another contrasting colour. Let's go for light blue. Hopefully that's not too bad. So again, no need of rearranging on this one. This seems quite straightforward. So we've got dy over dx equals 6 minus 2x. And then for step 2, I then need to find the gradient of the tangent. So that's dy over dx. And again, I'm going to substitute x equals 4 into my DYDX, in which I get 6 minus 2 lots of 4, which equals minus 2. So my m is minus 2. So then what I then need to do is find the respective y-ordinate. So I've got y 6 lots of 4 minus 4 squared, which means 10 minus 6, sorry, 24 minus 16, which leaves me with 8. So my ordinate is going to be, so my coordinate rather, is going to be 4, 8. So then using minus 2 as my gradient, 4, 8 as my coordinate, substituting it all in, I get y minus 8 equals minus 2 x minus 4. And then just going on to simplify all of this, we get an equation of minus, I don't know why that looks there, minus 2x plus 16, and there is the equation of our tangent. So moving on to example 4, by getting rid of all that. And again, let's pick another contrasting colour. Let's go for purple this time. So as I've got a square root, I probably need to do some rearranging, or so rewriting I should say rather, in terms of using indices. So 6 root x is the same as 6 times root x, and if you remember in terms of indices, I can write that as 6 times x to the power of half. So the equation I need to work with is 6x to the power of a half. So what I'm going to do is use this equation to help differentiate it. So then dy over dx is going to be equal to a half times 6, which is 3, and it's going to be x to the power of minus a third. So then working out the gradient of the tangent, I need to substitute the x ordinate into this. And so substituting 4 into this, I get 3 times, and it's going to be 1 over the square root of 4, which is 3 times a half, which is 3 over 2. So the gradient of the tangent in this case is going to be 3 halves. So Moving on to the third step, which I need to now find the y ordinate. So y equals, and all I'm going to do is substitute 4 into this expression. So I've got 6 times the square root of 4, which equals 12, because obviously root 4 is 2, and 6 times 2 is 12, giving me a coordinate of 4, 12. So now what I'm going to do is substitute this coordinate and that gradient into the equation of a straight line. So I've got y minus 12 equals 3 over 2 x minus 4. Now, using our knowledge of working with equations of a line, as I've got a fraction here, I'm just going to multiply everything by 2. So moving the 2 over to the side, so I've got 2y minus 24 equals 3x minus 4. And then I get 2y minus 24 equals 3x minus 12. And then chucking everything all onto one side to make it a little bit easier for us to see. So let's go for, we can leave it as a fraction of this. And again, how you write your answer could be completely different to how you want to write it. So I'm going to go for 2y minus 3x equals 12. And there is your final answer. Again, you can make it equal to 0. You can leave it in its normal form. You can leave it as using fractions. It's entirely up to you. But as long as this is usually the same, then you're going to be absolutely fine. So moving on to our last example, which is looking at example 5. So in this we've got 3 terms in our equation, and as I said, it just doesn't make any difference at all to the actual final question. It just requires a little bit of care and a little bit extra working. So from this, as you can see, we've got no fractions, no square roots, so I can just leave it as it is. So working with dy over dx, so let's start off by getting a different colour. Let's go for, what colour have we not used? Let's go for red. So here my dy over dx is going to be equal to 3x squared minus 2x. So obviously the 2 cancels out. So to find the gradient of the tangent, I need to substitute the x ordinate into DYDX, in which I get 3 times 1 squared minus 2 times 1, which just becomes 1. So my gradient there of the tangent is 1. I then need to find out what the y ordinate is going to be. So I've got y equals 1 cubed minus 1 squared plus 2. So I've got, that's equal to 1 minus 1 plus 2, 0, and that just equals 2. So my coordinate I'm going to be using is 1, 2. So using this as my step 2 as my gradient, step 3 as my coordinate, I then just got to substitute this all into my equation of a line. So I've got y minus 2 equals 1, x minus 1, and then just expanding the brackets out. So let's get rid of that equals and do it a little bit slower. Equals x minus 1, and then lo and behold, the final equation is going to be y equals x plus 1. So hopefully I've showed you there just a bit of an understanding of what it is to work out the equation of a tangent. The key point in this is that step 2, by substituting the x ordinate you've been given in the equation will into dy dx, automatically gives you the gradient of the tangent. And so now what we're going to move on to is the equation, how to work out the equation of the normal. So moving on to the equation of a normal from working out the equation of the tangent. So what we're going to do now is we're going to have a go at these 6 examples. Now I do have to give you a bit of warning. If you look at the equations that we're actually going to work through, they are quite complicated. But hopefully if you were to come across any of these questions in either your textbook or your exam, hopefully by listening and working through these problems, you'll get more of an understanding about what it is we do when we face these types of questions. So getting started then, let's start off by picking one particular colour so we can differentiate between the questions. So let's start with green. So with question 1, as you can see in the original equation we've got no fractions, so I can go straight on to working out what my dy over dx is going to be, which in this case is going to be 2x minus 3. Then following on with the second step, the next thing I then want to do is I then want to substitute the x ordinate, which in this case is 2, into my DYDX, which therefore gives me positive 1, meaning that my gradient of my normal is going to be the negative reciprocal of this, which is going to be minus 1 over 1, which equals 1. So this is going to be my m value. Moving on from that, we then need to find the respective y ordinate. So I do that by substituting the x ordinate into the original equation. So remember not to do it with DYDX, which is where a lot of students go wrong. So here we've got, it's going to be 2 squared minus 3 times 2, which gives me a y ordinate of minus 2, which then gives me an overall coordinate of 2 minus 2. So what I'm now going to do then is, using the m as 1, my x1, y1 as 2 minus 2, I'm now going to substitute it into the equation of a straight line, which I'm just going to write out again so you can see where everything's coming from. So substitute everything in, we get y minus minus 2, which becomes plus 2, and then we've got 1x minus 2. Now if I go about rearranging this, I should come up with y equals minus x. And again, there's different variations in which you can write this. I could write this as y plus x equals 0, or I could leave it as minus x, well, as it is, or I could leave it in its form where I've just, all I've done is substituted it into the equation of a straight line. So moving on to our next question, just while I carefully delete all of that. So next thing we then do is start off by picking a different colour. So in this case, let's go for orange. So with question 2, you can see that I've got a fraction. So what I'm going to do underneath here is I'm just going to rewrite that as using indices, because obviously using indices makes it a little bit easier for me to differentiate it. So this then becomes 6 minus x. Now because I've got reciprocal, it becomes minus, and the original power was a 2. So this is the form I'm going to differentiate the original curve by. So I've got dy of dx equals, now the 6 is going to disappear, the minus 2 moved to the front, then becomes positive 2 because there's already a minus there, so it becomes 2x to the minus 3. Then substituting my x ordinate into my dy dx, which in this case is equal 1, and that should give me a value of 2, meaning that the gradient of the normal is going to be minus a half. Then finding the respective y ordinate, I've got 6 minus 1 over 1 squared, which gives me 5, which then gives me a coordinate of 1, 5. Then substituting all these two things into the equation of a straight line of y minus y1 equals mx minus x1, I'm going to get the equation of y minus 5 equals minus a half x minus 1. Now as we've got a fraction again, I could, as there's no indication of how they want the equation written, I could leave it in this form. However, I'm just going to simplify it by multiplying the 2 across. So I get 2y minus 10 equals minus x plus 1. Again, on the left hand side, all I've done is multiplied everything in the bracket by minus 1. And then that then becomes, another formation of writing this would be 2y plus x equals 11. So again, I'm kind of switching between how I'm writing the final answer just for whatever looks neater and what appears to be neater when it's coming through this. But like I said, in an exam, if it's not mentioned how they want the answer written, you can write it in any form as long as it is correct. And it's also important that when you're, especially when you're looking through textbooks or looking through mark schemes, that you're aware that sometimes your answer might be different to what's written there, but they both may mean the same thing. So look at the additional notes if you are working through an exam paper. So moving on to our next example, let's go for blue. So again, no fractions involved in question 3 or no square roots, so I can go straight into working out what my dy over dx is going to be, which in this case is going to be 3x squared plus 4x. So then substituting my x ordinate into my dy dx, and I get a value of 4, meaning that the gradient of the normal is therefore going to be minus a quarter. Then finding our y ordinate, so I've got to substitute minus 2 into this. So I'm just going to write it out in full so you can see exactly where and what it is I'm actually doing. And that should give me a value of minus 3, which then gives me a coordinate of minus 2, minus 3. So again, what I'm going to do is I'm going to substitute the step 2 as my m, step 3 as my coordinate, and I'm just going to go straight into substituting that into the equation of a line. So minus minus 3 becomes plus 3. I've got minus a quarter, and I've got x minus minus 2, which becomes plus 2. Again, taking the 4 over to the other side, I get 4y plus 12 equals minus x minus 2. And then simplifying that, I'm going to get 4y plus x equals minus 14. And again, if I wanted to, I could write this as 4x plus 4y plus x plus 14 equals 0. So again, loads of different ways in which you can write down your final answer. It's entirely up to you, especially if it's not specified in the question. Noted I had a different change of pen there, but there you go. So moving on to example 4, and with that we choose a different colour. Let's go for this cyan colour. So again, with question 4, I have got a bit of a fraction. So what I need to do is use indices to try and sort of write this in its more easier way for me to differentiate. So here I've got y equals x minus 3 over x squared. Now one thing to notice, I've only got one term as a denominator, so I can split this out as x over x squared minus 3 over x squared. Now this simplifies to be, if I write a 1 there, 1 take away 2 becomes minus 1, so I can write that as x to the power of minus 1, and I can write this as 3x to the minus 2. And again, if you're not too sure, it might be a case of just revisiting indices and we go from there. So this is what I'm going to be differentiating. So once I've got that, I can then work towards differentiating that rather easily. So in this case, we've got minus x, because I move the minus 1 to the front, and it then becomes minus 2, minus, and then it's going to be plus 6x to the minus 3. So then substituting my x ordinate into my dy dx, which in this case is minus 1, and if I substitute that straight in, I get minus 7, which then gives me a gradient of the norm of the negative reciprocal of that, which is just going to be positive 1/7. Then substituting my y ordinate, to find my y ordinate, substitute my x ordinate into the original equation, so I'm going to get minus 1 minus 3, which is minus 4, over minus 1 squared, which is 1, which gives me minus 4, meaning that my coordinate I'm going to be using is minus 1, minus 4, and then substituting that straight into the equation of a straight line, so I get y minus minus 4 becomes plus 4 equals 1/7, and it's x minus minus 1, which becomes plus 1. And then again, expanding the taking the 7 across, I get 7y plus 28 equals x plus 1. And then you can either rewrite in this in any sort of shape or form. Let's just go for 7y minus x plus 27 equals 0. And there is one possible way of writing your final answer. So moving on to example 5, again I've got a fraction there, so I need to think about potentially rewriting this. Now again, with practice, some of you may go straight on to going straight on to simplifying without having to write it down. But again, that's entirely up to you, depending on how confident you are and how able you are of doing it correctly. But it's worth not taking any risks, not being a hero, because like I said, at this particular stage, careless mistakes can easily be made. So moving on to question 5. Again, let's pick a colour that we've not used. Let's go for what's going to come up well? Green. Let's go for a darker green this time. So with regards to question 5, I've got y equals 3 minus 36 over x squared. So I just need to rewrite this here, which then becomes 3 minus, the numerator goes in front, and I just mess around with that denominator with a minus power and the power staying as it is. So working out my DYDX from that, I get my DYDX value as, now the 3 just disappears, I've got minus 2 times minus 36, which is positive 72, and I lower the power by 1. The next thing I then need to do is substitute x equals 3 into minus 3 into my DYDX, which then leaves me with minus 8 over 3, meaning that my gradient of my normal, now again, if you think back to when you're working out, if you look at the perpendicular lines, we flip the second fraction, we flip this fraction and we change the sign, so it then becomes positive 3/8. Now the next thing I've now got to do is work out the respective y ordinate, so that's going to be done by doing 3 minus 36 over minus 3 squared. Now note that if I'm using my calculator, I'm going to put any negative numbers in brackets, which leaves me with minus 1, meaning that my coordinate is going to be minus 3 minus 1, and then substituting those 2 bits of information that we've got here into the equation of a line, and we're going to get y plus 1 equals 3/8 x plus 3. Multiplying the 8 across, we get 8y plus 8 equals 3x plus 9, giving me a final way of writing this answer of 8y minus 3x equals 1. So moving on to our last example with regards to question 6, and as you can see, we've now got square roots. So what I need to do first is rewrite those square roots using indices. So again, remembering that how I can write a square root is to the power of a half. So that's going to be 3x to the power of a half plus x to the power of minus a half. And again, because I've got reciprocal, that's where the minus becomes, and then I've got root x, which is just x to the power of a half. So now what I'm going to do is I'm now going to DYDX this particular expression, in which if I do just that, I get, move the power to the front, so half times 3 becomes 3 over 2x, a half minus 1 becomes minus a half, and then I move the power to the front, which then becomes minus a half, and then x minus 3 over 2. So as you can see, it does look very messy because I've got fractions, negative powers and negative signs, but I've just followed the simple rules of differentiation. Move the power to the front, lower the power by 1, regardless of whether it's a fraction or a negative number. So moving on from that, the next thing we then need to do is substitute my x ordinate into my DYDX, which is a quarter. So if I substitute a quarter into this, what it's going to look like is a third. Now if you're using your calculator, you might find it easier just to use 0.25, which is fine. I'm just going to go for straight into substituting into the fraction. And again, making good use of brackets, because remembering that it's only the quarter that's being risen to the power of minus 3 over 2, and that should give me minus 1, which means then the gradient of the normal is going to be positive 1, and that's from minus 1 over 1. So from this, the next thing we then need to do is work out the respective y ordinate. So again, all I'm going to do is substitute a quarter for my x, and that should give me a y ordinate of 7 over 2, meaning that the coordinate I'm going to be working with is a quarter and 7 over 2. So again, this question awfully messy, but again, to make questions more difficult, all they need to do is introduce fractions, introduce thirds, introduce negatives, but this, again, the job is still the same. So working with those two bits of information, so here I've got my gradient, here I've got my x1, y1. I'm now going to substitute this into the equation of the line. So I've got y minus 7 over 2 equals 1x minus a quarter. Now from this, as you can see, although I haven't got a fraction here, I have got a fraction there. So if I just get rid of that bracket on the left hand side and not forget to write minus, let's try that again. So we've got minus 7 over 2 equals x minus a quarter. Now at this stage, again, I could either work with fractions if that floats your boat, or I could try and eliminate the fractions by multiplying by, let's say, a number. Now if I multiply everything by 2, I'm still going to end up with a fraction here, whereas if I multiply everything by 4, this will then, again, although I'll end up with 4 times 7, which equals 28, divided by 2 gives me 14. So what I'm going to do is I multiply everything by 4. So this then becomes 4y. 7 over 2 times 4 is 14. X times 4 is 4x, and a quarter times 4 is 1. And now you can see I've eliminated all use of fractions, so all I need to now do is make this a little bit easier to appealing to the eye. So what I'm going to do is I'm going to stick all my letters on one side, stick my constant on the other, and there is your final answer. So in the examples of find the equation of the tangent and the normal, I haven't picked nice easy questions. I may have gone a little bit into the next level. However, if you can work with indices, if you can work with square roots and fractions, then the method is exactly the same, and that's hopefully what I try to translate in this video. If you have any problems or would like additional questions on this particular topic, feel free to email me at 162maths@gmail.com.